familiar. So I'm not sure if these PowerPoint slides line up with what you have there. But for instance, wake up. For instance, doesn't want to go. Oh, there it goes. Okay, so one of the things we talked about in chemistry is the idea that there are special electrons. They're valence electrons in the highest end, right? Okay. So, are you okay?
Yeah.
So this is a bunch of review. I don't have bills, so you can use, if they're main group elements, you can use their group number to know how many valence electrons they have. And of course, the 8A elements, this over here, these guys right here, they have 8 valence electrons. So they would have Roman numeral 8, the VIII, you told me. Okay, so 8 valence electrons. And the thing is, the non-metals pick up electrons to be like the rare gas in front of them, and the metals would kick off electrons to be like the rare gas in the period above them. So we talked about if something's electrically charged, that means the number of protons and electrons aren't even. We have these versions of ions. We have when a single atom loses an electron, becomes a cation, gains electrons, becomes an anion. Those are monoatomic ions. And then actually today's lab is broken up into 3 segments. And the first segment is just monoatomics, and the second section is shorter, it's monoatomic. The third section will be dealing with the things like nitrates, the polyatomic ions. And today we're going to be comfortable, because I'm already pretty comfortable with it, with writing the formulas of a neutral formula for an ionic compound and then also naming them. So that's the 2 things we're going to do today. So monatomic ions, we said, so what, is it the metals or the non-metals form cations? Metals form cations, yep. And so non-metals form anions. Oh, exactly. So this is kind of showing you see the JAG here. You told me that metals form cations and non-metals form anions. Now this is not all inclusive. I think years ago when this was put together, just kind of ran out of steam to put all those possible cations. If we find iron, we have something we talked about the other day, iron 2 and iron 3. So when something is forming a cation, of course it's a metal forming a cation, it's going to lose all of its current valence electrons. And then we said that for the ion, the cation, now its valence electrons are in the n-1, what it used to be.
And we can do that in my workplace class if you want.
So the other day, and I think I've got mine here, I told you to put a +1 over group 1A, a +2 over 2A, and a +3 over the 3A metals. Remember the metals, you have to go under the JAG to pick up a little one. Okay? Good. Then the non-metals, they tend to pick up electrons. The 5A pick up 3 electrons, the 6A pick up 2 electrons, and the 7A pick up 1 electron. So that's why on your periodic table, if you had it handy or can draw your current one if you want to, that's why you put -1 over 7A, -2 over 6A, and -3 over 5A. So that's the sort of information you're going to be using today, especially in the first part. So this is where, and I kind of tease that sometimes students feel overwhelmed with memorizing because you do have to memorize like nitrate. Yeah, that's a little overwhelming. I'm going to try to give you some tricks for knowing nitrate is NO3 - 1, but you don't have to memorize these monoatomic ions, the group A elements. You don't have to. So again, this is something that we talked about, the crisscross that we did yesterday. We said basically when you crisscross, you're trying to get a neutral formula, okay? And remember we ran into something where we crisscrossed and we had 2 and 2. This in bold is explaining why we had to divide the 2 and the 2 by 2, and now our new scripts were really 1 and 1. So if you can reduce it, you need to reduce it, okay? This talks about the fact that when you write the neutral formula, you don't include the charges because you're assuming that somebody who looks at NaCl can find Na and know it's a +1 because it's 1A. They can find Cl and know it's 7A, so it's a -1. So you don't include the charges. The other thing is, like, if you needed more than one nitrate, you'd have to put that whole NO3 quantity in parentheses, and then to the lower right, you'd have to put the number of how many of those polyatomic ions you needed. So we'll get some work at that. So if we crisscross, if we went to our cation closet, we pull that magnesium. It's a 2A element, so we know it's going to be +2. Chlorine is a 7A, so we know it's going to be -1. So you know these by finding them on the periodic table. Now, if we crisscross, make the magnitude of the charge on the cation the number of anions we need, and the magnitude of the charge on the anion how many cations we need. Don't forget, these have to be subscripts. Then we have the neutral formula unit, just MgCl2. This actually, NH4+, some of you may know, is the polyatomic ion ammonium. CO3 -2 is the polyatomic ion carbonate. So this is ammonium carbonate. Now notice we crisscross. If we crisscross, we need 2 NH4 groups. So that's why you write quantity NH4. Outside of that, you write a 2. The number of CO3 groups we need is the magnitude of the charge on the cation, which is 1. Okay. For my other class, my intro students, sometimes I will accept them to go ahead and put a quantity around that CO3 and put a 1 out there. But for y'all, I'm looking for just a little more. Okay. Oops. Okay. So we talked about when you go, you're going to have to be able to crisscross. I call it crisscross. That was all. And then make the neutral formula of the ionic compound, and then you're going to have to name it. So you name it kind of like the order as it's presented: the positively charged cation and negatively charged anion. So have first and last name, just like people. So again, this is a review slide, stuff we already talked about in lecture. We said that in order to name the positively charged cation, probably a metal, if it only forms one possible cationic form, only one possible ion, then you don't have to give it a Roman numeral. So we kind of ended with that aspect, I think, in lecture yesterday. So remember I told you that if you go back, if you picture periodic table, marking it up, now on your unit exam you can't bring yours marked up, but on your final you can. On your final exam you can bring a marked up periodic table. So if you picture that you have a +1 there, a +2 here, a +3 here, you're like, well, I know that I don't have to use Roman numerals because I know it's +1. Don't have to use Roman numerals because I know it's +2, and I know it's +3. And then what the slide says is there's 3 kind of hiding in the transition metals, and they are zinc, cadmium, they're +2, and then go to the left, and it's silver, and that's a +1. So +2, +2, +1. So if you know what it is, you don't have to use your Roman numerals. That's the deal of it. Okay. Cool. It's just like that. Now this finally is a slide we didn't get to yesterday, but I'm thinking you guys have these names already. Cool. So this, if you want to put a star here for this slide, where it has this slide, you might be referring to that when you go to name them. So if it's a monoatomic, now picture what monoatomic, a 1-atom anion, then it ends in IDE. I know I feel rude, IDE. The reason I enunciate the D heavy is because here in the last part we're going to talk about something called, for instance, sulfite. It's not up there, is it? Okay, but what is up there is sulfide. Okay? Sulfide, 1 atom. We know it's 6A, so that means it's going to pick up 2 electrons and be a -2 charge. We just know that. Okay, so basically with these monoatomic anions, you lop off the end of the name and you replace it with ID as in dog, E. Okay? Ready for part 1. So what I'd like to do, the way I told you it's 3 parts, and you can work together and all that. You know, groups 2, 3, 4. But I'm gonna do an example up here. My stylus doesn't work, so I'm gonna do it right over here. for each of these parts, and I would encourage you not to go on to the next part until we kind of talk about the difference between the parts. You should have plenty of time. Now, if I've given a little bit of time and people are almost done, not quite, I might move on to the next part with everybody. And I'm going to give you an answer key before you leave. Okay? That's kind of how this works. And I mentioned 2 opportunities for 10 points extra credit, and I'll kind of talk about that as they come up, okay? So the parts each have kind of a top part and the bottom part. I'm looking at the answer key right here. And the top part is where you're given what's called the component ions. So let's pick on E. So we'll do E together. So this is E in your part 1. So the component ions are Mg plus 2, comma, P 3 minus, or minus 3. Those are my component ions. I'm just so excited. You go to the cation closet, you go to the anion closet, and there you go. So for each of these, I want you to do 2 things. I want you to crisscross, and then I want you to name it. So if I crisscross, how many magnesiums do I need? 3. Very good. I'm make sure that's a subscript. And then how many phosphoruses do I need? 2. Are we good with that? Then the next thing is, what's the first name of this compound? Magnesium. It's just magnesium, yep. What is the last name? Phosphide. Very good. Phosphide. Okay with that? So let's take a look at the second part. Let's go with potassium nitride. So now, and actually on your test, this is kind of how it's going to go too, kind of. I'll kind of try to tell you what will be different on your test. So we have a name, potassium nitride. Okay, and I would encourage you, if you have to, we're on our way to write the neutral formula, but as in these exercises, when you run into it on a test, I really strongly urge you to write the cation and the anion, to write the component ions. Okay, I'll do a semicolon. So what's the symbol for potassium?
K.
It is K, special K. And what sort of charge will it form? So now you need to find out a periodic table.
+1.
A +1. Cool. What about nitride? What are we talking there? Right, nitrogen, symbol for nitrogen is N, and -3. Okay, just finding out the periodic table. Now, if you get this right, and I'm hoping everybody get this right, then when you crisscross, you are done. You are golden. So how many K's do we need? 3. I'm liking it. Let's make this subscript. How many N's do we need? Just 1, and I'm not going to put the subscript 1 there. Okay, so I'll give you a little bit, and go ahead and kind of do those. Again, you can work together, work on your own. You can look at your neighbors.